to go over some more paleo news here, and again, being part of the Paleo Journal Club at Sam Neill Museum, which shows up during the semester, they provide a couple of papers, usually short, and they try to go with a theme about this, and which is not always. Last one I did was on trilobite eggs and a way of measuring embryos through tooth growth. So this one is going to be on a couple other papers here. For the record, I did not join up to the meeting for this because where I work at a grocery store, they had a company meeting. We all who could had to show up, so I had to miss out because of that. But I read them all the same, and I'll link them down below. This one published in Nature by Jianhan et al. Meiofaunal deuterostomes for the basal Cambrian and Shaanxi, China. Sorry if I'm mispronouncing the Chinese there. And it's very interesting because it deals with deuterostomes, which includes us. One of the things that it also includes sea urchins, acorn worms, and a few others. And the thing about them is that one of the sciences during our development, when you are just a few cells that form into a ball, there's going to be a point where those cells are going to dip into a cavity, and this will later grow into the intestinal line. Now, in protostomes, the other group, that starts with the mouth first. Dueterostomes starts with the anus first. Yes, we all start off with life as assholes. Some stay there longer than others. So, biological proof of that aside, here we have an example of a species, Saccharodidae. Let me see if I can get the actual name of this. Saccharodidae coronarius. What I said before was a family name. I'll read the abstract here. Dueterostomes include a group we belong to, the vertebrates, as well as an array of disparate forms that include echinoderms, hemochordates, and more problematic groups such as vetulicolians and vetulocystids. The Cambrian fossil record is well populated with representative examples, but possible intermediates are controversial, and the nature of the original Dueterostomes remains idolized. Excuse me. Here we report millimetric fossils, Saccharodidae coronarius, from the Orstern-like Lagerstätte from the earliest Cambrian period in South China, which stratigraphically is amongst the earliest of Dueterostomes. The bag-like body bear a prominent mouth and associated folds, and behind them up to 4 conical openings are on either side of the body, as well as possible sensory structures. An anus may have been absent, and correspondingly the lateral openings probably serve to expel water and waste material. This new form had similarities in both the vetulicolians and vetulocystids, and collectively these findings suggest a key step in deuterostome evolution as the development of lateral openings and that subsequently were co-opted as pharyngeal gills. Depending on the exact phylogenetic position, the meiofaunal habit of Saccharodidae may help to explain the major gap between the divergent times seen in the fossil record and estimates based on molecular clocks. Now, I wish I got into the meeting just to be filled in on those who studied this more thoroughly. But if you look at the slideshow, that big round thing with a mouth and looks like it has a row of teeth on the outside, like some bad alien or horror movie, yeah, that's Saccharodidae. And I would have asked the fact that because usually when you're told in biology about deuterostomes, it's usually we start from the anus first, and this one it just says that doesn't have an anus, or maybe it probably serves as both, like hydras, not the mystical hydras with the multiple heads, the little these little tiny near microscopic two-light bodies with little tentacles that are related to sea and jellyfish and all that. They're cnidarians. Because they have one opening too, but it serves both purposes. It takes in, it grabs in food in its mouth, but it also can expel waste through the same opening. Maybe this is a similar thing. I wish I could have talked to them about this. But that's a nice little find, and, it is kind of neat seeing the actual photographs and seeing the reproduction of this. And the fact that these little microscopic things are just floating around. Let's see if I can see diagnosis. What's the what I'm trying to do is look for the size of this thing. The body is hemiellipsoidal with a maximum length of 13,000 micrometers, width 1,800 micrometers in height, and 900 micrometers in length is 1,300 micrometers, width 1,800, height 900 micrometers. Very, very small. And you can see from the detailed photographs, so like I showed pictures of the slideshow, but one of them is not too great. But you look down below and you can see the link, and you can find the photographs of cells, and it even gives a nice phylogenetic map of where it fits in, and it fits as an outgroup to both the not to the chordates, which includes us, but on the other branch, which is the outgroup to Vetulocystids and Vetuliocolians when they did the analysis. I'm going to read the last two paragraphs. Very few characteristics unite the Dueterostomes, and only the pharyngeal openings are potentially fossilizable. In this context, body cones of Saccharidus are more similar to the apparently equivalent structures found in Vetulicolians and Vetulocystids than they are with the pharyngeal structures of other Dueterostomes. Early Dueterostomes have a through gut, so the apparent absence of an anus in Saccharidus could be secondary, as in brachiopods and ophiuroids. It remains possible, however, that this feature was inherited from more primitive bilaterans, possibly links to the acyls and the xenoturbulates. It's a very important fossil, of a possible intermediate. I guess that's the theme with these two journals, is that they are now representatives of intermediates between groups that were not so. I'll get to that a little bit about the pterosaurs. We draw two main conclusions. First, some of the earliest dueterostomes are Meiofaunal, and this finding complements proposals that such animals were benthic worms. In contrast, however, to the suggestions that earlier dueterostomes possess an indirect life cycle with a feeding larva. The biology of Saccharidus seems more consistent with direct development. Previous work has emphasized the possible importance of the first stage of metazoans evolution occurring in a Meiofaunal context. The discrepancy between the known fossil record and the early metazoans and their estimated time of divergence, as based on molecular clocks, suggested that such miniaturized forms could slip through the nets of most fossilization pathways and so help them explain this cryptic history. Second, the body cone openings of Saccharidus are consistent with Dueterostome body openings being very primitive. In Saccharidus, however, diffusion across the body surface would have met respiratory needs, suggesting that the transformation to specifically pharyngeal slits was linked to the increase in body size. If Saccharidus lacked an anus, body openings may have originated to dispose of waste materials. So there you go. You look into it, especially if you're interested in invertebrate paleontology, there you go. And of course, through this leads into the group that will involve vertebrates. So a nice little important find. On the next paper I'm going to look into, it is, let's see, from Chengfu Zhao et al. Again, this is from found in China. Earliest filter-feeding pterosaur in the Jurassic of China and ecological evolution of pterodactyloids. This is published in a Royal Society Open Science. I've published down below. And the abstract of this: pterosaurs were a unique clade of flying reptiles that were contemporaries of dinosaurs in Mesozoic ecosystems. The Pterodactyloidea, as the most species-diverse group of pterosaurs, dominated the night sky during Cretaceous times, but earlier phases of the evolution remain poorly known. Here we describe a 160 million-year-old filter-feeding pterosaur from Western Liaoning, China, representing the geologically oldest record of the Pterochasmatidae, a group of exclusive filter feeders, characterized by an elongated snout and numerous fine teeth. The new pterosaur took the lead in a major ecological transition in pterosaur evolution and fish catching to filter feeding adaptation. Prior to the Tithonian, which is 145 to 152 million years ago, I believe that's Jurassic, diversification of the Pterochasmidae, our research shows that the rise of Pterochasmid pterosaurs were followed by a burst of ecomorphological divergence of other pterodactyloid clades, which involve a wide range of feeding adaptations that considerably altered the terrestrial ecosystem of the Cretaceous world. This is a pterosaur found in China, and is a holotype. It's the first of its kind, and it's found by a couple of vertebrae and a complete skull, not much of it. But the interesting feature is its teeth. When looked from above, the teeth are spread out. Now, before this species, most pterosaurs were either piscivores, meaning they eat fish, or insectivores. They eat, they would eat bugs and whatever it could catch. This is the start of another branch of pterosaurs that will give rise to filter feeders. And let's see. Let me expand that graph. You can see from the graph in the slideshow the phylogenetic tree involved with that. The species is Leondactylus, and from look at the phylogenetic chart, it is, they place it well within the group of the Pterochasmidae, which is a group of filter feeders. Yeah, they have teeth right now, but later, as in, what was it, Pterodaustrini, which has a very specialized bill. It kind of from its snout, it kind of curves in almost a shovel-like shape, and it has teeth modified for filter feeders similar to baleen in whales. So here we have a group within in the late Jurassic that would later give rise to this other group of pterosaurs that were more specialized in filter feeders. So that is very interesting about that, especially if you like pterosaurs. And after reading Mark P. Whitten's book of pterosaurs, you can't help but be fascinated by the diversification of these. So that's, I think, okay, really not so much. I always advise, look now below so you can see it yourself. It's not that long. The PDF is like 8 pages, and of course some of that is the the research part. But let's see. Let me read the let's see, which is a good part to look at the end. Let's see. The rise of the Pterochasmidae clade signifies the first major ecological shift in pterosaur evolution from insectivores, piscivores to filter feeding, followed by a second and more dynamic transition into Cretaceous times, as evidenced by the surge of species diversity and ecomorphological differentiation of pterodactyloid clades. However, primitive pterodactyloids also display relatively low ecomorphological diversity. Besides the filter-feeding Pterochasmidae, other families of this group from the late Jurassic of Germany and the UK were essentially fish eaters, although their diet might also have included invertebrates. Now see electron developmental material. Let's see. The most striking morphological difference in pterosaur evolution occurred when the forgive me for I'm not familiar with this word, Pterodactyloidea, a group of advanced pterodactyloids. During Cretaceous time, at least 55 species and 11 families within the Pterodactyloidea had engaged in a variety of feeding adaptations, including filter feeding, fish eating, carnivory, and scavenger. Herbivory, including frugivory, mollusk skull crushing, durophagy, and omnivory, except for the filter feeding and fishing boreopterids. Other can't see how Pterodactyloids clades display essentially unified feeding habit within each family. The early Cretaceous isotodactylids were razor edge and interlocked teeth have been regarded as predatory carnivores, whereas the late Cretaceous arthropods, with their giraffe-sized bodies and enormous but edentulous jaws, have been hypothesized as foragers feeding on small animals and carrion in diverse terrestrial environments. The early Cretaceous tapagerids may have been herbivorous, as inferred from their short, high-profile skulls with their prominent dorsal crest and parrot-like beak. The early Cretaceous Eurypterids were most likely mollusk shell crushers, and evidenced by their tweezer-like beaks and robust crushing dentition. Fish-catching pterodactyloids involved 4 families: ornithochirids, boreopterids, were typical fish catchers with long jaws, large and loosely spaced teeth, whereas the nyctosaurids and pterodontids, with their large skulls but tapering toothless jaws, were suitable for seizing fish in open water environments. In addition, several families were probably omnivorous, as they lacked skulls and tooth features for a specific type of dietary preference. To sum up, the new fossil discovery reported in this paper documents geologically the earliest record of filter-feeding pterosaurs, marking the initial step in ecomorphological diversification of pterodactyloids from insectivorous piscivorous to a variety of feeding adaptations. Combining our phylogenetic results to morphological analysis reveals patterns of pterosaur evolutions. The first 55 million years of pterosaur evolution were characterized by low ecomorphological diversity, with only insectivorous piscivores involved. The rise of the Ctenochasmidae in the late Jurassic marked a major ecological shift within the pterodactyl clades. This ecological transition is followed by a burst of species diversification, ecomorphological differentiation of pterodactyloids, which significantly alter the terrestrial ecosystem of the Cretaceous world. So there you go. 2 papers here. Now again, I'll link them down below. Have a look at them, because if you want to study what's up there, it's good to go right to the source of the journals. Thank you very much for watching. You all have a nice day.